Okay, class. We start for the chapter 2. Chapter 2 is Vienna Development Method, or we call it as VDM. VDM. Okay, VDM is a very formal approach that mathematically oriented method for specification of the system. Uh, and for development of the software in general. Formal specification language fall into two main classes. Uh, this one is algebraic languages and model-oriented languages. VDM is model-based languages. Okay. Okay. Last week we are saying a lot of formal specification. Okay, we have a formal specification. Okay, fall into two main criteria. The first one is algebraic languages, and the second one is model model based. Okay, model based method lah. Okay, and for VDM itself is categorized or classified as a model based methods. Okay, saya contohnya lah kat sini. Kamu refer later lah. Okay, okay, as a model based method, VDM is a environment for modeling and development of sequential software system. The specification language of VDM has evolved from Meta 4 languages used at IBM, Vienna Development Laboratory, for specifying a semantic of PUI programming language in early 70s. Okay, VDM evolved. This one is evolved from Meta 4 is a language that developed by IBM. Okay. Okay, as you can see, this one is in the early 1970s. This one, 1970s. Okay, and what is VDM used for? VDM is one of the longest established formal method for development of computer-based system. Okay, this one is for development. Okay, for the development of computer-based system. Okay, this one a little bit of history. Okay, we evolved in from a metaphor developed by IBM. Basically, this one in 1970s, and then it has the development purpose basically for the computer-based system. Okay, so far, do you have any questions? Ada soalan ke? Is it okay? Okay. Okay, basically, if you talk about VDM, specifically for software engineering, Formatted technique used by many of the software engineers to design a safety critical system and also for their components. In software engineering, the technique that evolve mathematically expression to model the abstract representation of the system. Okay, basically used by the software engineer. Okay, used by the software engineer to design safety critical system. Okay, safety critical system we have discussed last week. Example. Okay, we have a healthy uh, or medical, okay, system. Okay, other than that, medical system, aviation, okay, is very safety critical and so on. Okay, and also their components and components for the safety critical system. Okay. Okay, what is the example for VDM? Uh, okay, example is for the reasoning that running people over any reason, for example, ramming a vehicle with a vehicle to cause it to explode, blowing up an empty vehicle, resulting in the death of someone who was not in the vehicle. Okay, this one is the example. And then the operation in a VDM. VDM, the development cycle from the abstract specification to the implementation, because it involves the modeling. And also refinement towards implementation. Iterate over several steps. And also it involves the data rectification. For example, from algebraic data type to concrete data structure. Therefore, later on, we discussing about uh, the data type from the structure data type into object oriented data type in VDM. Okay, okay, VDM. Okay, involve abstract specification because abstract specification because it involves the modeling. Okay, so specification. After that, we go by the implementation. Implementation. Okay, implementation. And then after that, we go by the refinement. And then after that, we go by modeling. Okay. Okay. Please take note. This one is very critical stages in VDM. Okay, refinement. First abstract specification, and then we go by the implementation, and also for the refinement, and finally we come up with the modeling. Okay, so far, do you have any question, Hani? Okay, ke? Hani Syaira, Zaim, okay ke Zaim? Okay, this one is the definition. Definition for VDM. Okay, VDM is a collection of techniques for modeling. This one I have described. Okay, it's a collection technique for modeling and also specification. Before we want to specify, okay, we need to collect abstraction specification before we go by the implementation, and then after that we go for the specification. And also we want to design a computer based system. Okay, this one I have explained. Computer based system based on the mathematical rigorous very rigorous process involving the formal specification. Okay, and then specification you have learned in a discrete math, a discrete structure. Okay, for the formal specification, okay, is involving the algebraic and also mathematical equations. Okay, later we can see we can have VDM SL and VDM plus plus. This one is model oriented from the VDM. Later on, we can have VDM SL and VDM plus plus. Both of these are model oriented. Okay, we want to model. Okay, in the 1970s, this one I also explained before this. It has grown to include a group of techniques from metaphor. This one from metaphor, and tools based on a formal specification language. Then we call it as the VDMSL, and extended form we have VDM plus plus. Okay, later I explain and explicate what is VDMSL and VDM plus plus. Okay, and then there is a history industrial usage of VDM, and its tool and a growing body of research in the formalism led to a notable contribution that we can see here is basically to design a safety critical system. Okay, engineering of critical system compilers. Okay, we involve a lot of compilers. For example, we have Java. Okay, Java, and then other than that, we have involve also for the uh, C C languages. Okay, all of the compilers involve for modeling. Modeling is required to model a critical safety requirement. Okay, other than that, we have Java, Ada, ADA, Ada. Kat lagi satu Okay, for the compilers is important to have a good understanding. We have compilers here. Okay, for example, you have Java, Ada, and then after that, we go for the UML, Unified Modeling Language. Why we use the Unified Modeling Language? Because we want to model the specification, model the specification. Okay. Okay. So far, do you have any question? Okay. For the UML modeling, it is specify the semantic of subject matter, and in that sense, indeed, we need a program for the subject matter. Okay, UML, you need to specify the subject matter. Okay. Okay. In this sense, you need the executable UML EXE lah. Okay, this one in the EXE formatting lah. Okay, executable UML model compiler turn into the executable UML model into implementation using a set of decision about the target hardware and software environment. Okay, because we want to use the VDM, this one is more on the executable. Okay, we want to use the model. Okay, modeling. Okay, in the sense of we want to UML model compiler into the executable model UML model. Okay, using the set of decision. Decision. Okay, later we discuss set of decision. It takes a lot of abstraction. Abstraction technique. It takes a lot of instances. Okay, set of decision. Basically, set of decision comply to the hardware and also for the software. Okay, and then after you model the UML, okay, you need the architecture to model UML into the specified subject matter, and then after that you go for the implementation. Implementation. After that, you go again for specification. Okay. Okay, this one is a brief introduction of VDM. Okay, this one compilers. Okay, so far, do you have any question? Okay, we have compilers and concurrent system, and in logic for the computer science. Okay, what is the example? Example of concurrent system? Do you have any idea? Concurrent mean it is processing in the same time. Concurrent system example ATM ATM and teller machine. ATM plus teller machine. It is a concurrent system. Okay, and then VDM continue. This one is just a continuation. Number of conventions that are not dictated by VDM has been used to increase the readability of the model. Okay, this one is just used to increase the readability of the model. They have also several syntax. This one is syntax for the VDM. Okay, first one is the type name of the model begin with the capital letter. Okay, and then the function name always begin with the capital letter. And then formal parameter and subject are always in the lower letters. And then our function specified to INS have the naming ended by the at INS and at EC for the specific function. This one for the syntax for the VDM. Later we see this one in details what is meant by the uh, syntax. Okay, why we want to standardize the syntax? Afiq, do you have any idea? Afiq, Muhammad Afiq. why we want to have the syntax? Afiq ada? Akif ada Akif? Kenapa agaknya? Why? Yang mana? Yang ni lah. There are several syntax for VDM. Why we must use some of the syntax? Apa dia? Tak dengar. Uh, okay, betul. The answer is to increase the readability. Okay, the readability is important because for the engineers to understand the model, we need the syntax. Okay, we need the syntax. Okay, for the model base, we continue for the model base. Okay, at 2:45 we take 5. 2:45. Remind me. Okay, for the model based languages. Okay, model base. Model base. Okay, model base. There are a number of different ways to write a precise specification. Okay, we have widely used VDM. Other than that, we have Z notation and B languages. Okay. Okay. First model base we have VDM, Z, and then we have B. This one is a model base. Model base. Okay. The characteristic of the model base is constructed using understood mathematical entities such as set, relation. Okay, model base view. Okay, by using the mathematical entities. Okay, mathematical entities such as we have a set. Later we see this one. Set, relation. Okay, and then we also have sequences and function. Okay. Okay, and then operation are also described by the predicates given in terms of pre and post condition. To have the mathematical entities, we also have the operation. Operation. Okay, and then the operation are also described by the predicate. Predicate you all dah belajar kan? Predicate dah belajar kan dalam discrete structure. For easing dah belajar kan? Predicate. Okay, predicate. Okay, for the predicate we have a pre and post. Pre and post condition. Okay. Okay, this one is model base. Model base. Okay. Okay, we continue. Okay, for the process oriented that I explained before. Okay, it has so many association. Okay, concurrent system also described using the process oriented formal specification languages. Concurrent system. Okay, a specific implicit model for the concurrency is basic for these languages. Okay, and then process are denoted and built by expression and also elementary expression, respectively, which describe the particular simple process by operation which combine process to yield a new potential and more complex process. Example, we have a communicating sequential process, CSP, for the concurrent. Okay, for the concurrent system, we can have CSP. What is CSP? Communicating a sequential process. Okay, this one is example for the concurrent. Okay, when you talk about the formal method style for the VDM, it is for the VDM itself is model oriented. It has the comparison factor for the mathematical basis is we have discussed about the theory set, predicate calculus, and then appearance differences for the VDM. We have a pre and post invariant that I have described before this, and then for the specification of state changes, we have before and after, pre and post, and then identification of input and output. Okay, there is no explicit way to specifying the process for the input and the output. Okay, this one is for the VDM. Later on, when we talk about the Z notation for the input and output parameters given by the operator header. Later we see what is a Z notation. Okay, and then for the communicating sequential process, we have several type of tool. For example, we have specbox or virtual and VDM tools. Okay, for the tools, for the tools. This one tools for the hardware. Hardware is not for the software. Software I have explained. We have Java, we have Ada, and so on. Okay. Hardware tools. We have specbox. Okay, we also have a virtual, and we have also VM tools. Okay. Yeah, I think we should take a break first because some of you